first step would be to determine the equation of the boundary line. And we do that by finding the slope, which is rise over run, and the y-intercept, which is going to be 0 number, right? And then we write it as y is equal to mx plus b. So when you're getting it from the graph, the easiest form to use is the slope intercept, okay? The second step would have to be determine if the solution or true region is above or below the line. If above, then you're going to have something like this, one of these two examples. But what remains is that it's greater than, right? Or greater than or equal. So if it's dashed or solid, that is also determined by the line. If below, then we have less than, right? And y is obviously isolated. And then we dashed if it's just like this, or solid, right? If it has the equal to. And it's important to note that if it's a solid line, then points on the line are part of the solution or are part of the true region. Whereas if it's a dashed scenario, the line is not part of the solution or the true region. So here, get your ruler out because we're going to have to graph and then and to help me make an accurate graph, I'm actually going to use my ruler and use the markings on here. So I just use the centimeters here. And I'm going to mark off every half centimeter, right? So mark there, because I want this. Normally you'll be given graphs anyways, nicely printed. So you won't have to make this as accurate when you graph it yourself. So I'm going half centimeter markings along the x-axis. I'm going to do the same thing with my y-axis. Every half centimeter. If you don't have a ruler, just try to do your best, okay, to make that graph. And so for our first graph, okay, this is going to give it away. It's going to be a little easier because we're actually producing the graph. But I'm going to ask you to put your first point at 0, 3, and another point at -2, 0. So the x and y intercepts are here. And I just want you to have those so you have a reference point, right? And we're going to draw a solid line connecting the two. So 0, 3 and -2, 0 are the two reference points that we should all have, right? This is your x-axis, y-axis. We're gonna make the top, like everything above the line, we're gonna make that true. And just so you get used to it, we will also start calling it the solution region. So it's both, okay? And then let's go ahead and shade in the top. So let's imagine now, let's go back and just imagine this just came up, right? Somebody just gave you this graphs, like let's come up with the inequality for this, okay? Let's review right away. What kind of shading is being used here, regular or reverse? Regular. Why is that? Let's think about it. Because the true region is being shaded, right? So just to make a note of that, okay, you notice that. Let's come up with the step 1 is to, if you go up and read step 1, it says determine the equation of the boundary line. So first step would be this. I would find the slope and I would find a y-intercept. That's what I would do. So you pick any 2 points on that line, okay? I would obviously now recommend you using these 2, but it doesn't matter. Just make sure they land right on an intersection. Don't pick a random point between a box, right? Somewhere in between. It has to land right on an intersection. And kind of just highlight them, right? This one, we're picking these 2 points. And there's a rise and run, okay? So how much are you rising and how much are you running? Okay. The rise is, if you count from down here, it's 1, 2, 3, right? And the run is from this point to that point, the run would be 1, 2. And this line is going up, right? From left to right. So I know it's a positive slope, right? Line goes up. Line goes up. I don't know, did I talk about Mr. Slope guy at the beginning? Do you remember that? At the very beginning? Okay, so you should have that on your study sheet to help you remember, right? If it goes like this, you should have a positive there. You don't have to include that, but I'm making sure it's there, okay? Y-intercept, it's very easy, 0, 3. Okay, so that's step number 1. So what we're gonna do is go y is equal to 3 over 2x plus 3. This is the boundary. That's the boundary line. We're not done yet, okay? Now comes the tricky part. Step 2, true is above, right? Therefore, y3 3 over 2x plus 3. So you write everything down except for the equal sign. You're now going to have to replace it with the appropriate inequality. So which one are you going to have to use? Right? If true is above, right, then we have to use one of these two. Since it's a solid line, we're going to use this one right here. So greater than or equal to. And this is what you're after. Will it take this many steps when you do it yourself? Absolutely not. Some of you will write right from the get-go, you'll go y blank, you leave a space for this, and then you'll write in your slope and your intercept, and then just come up with this after by looking at the shading and where the true region is and so forth. Okay. Just make sure this is based on where's the true region, not the shading. The shading is just telling you, is it reverse or regular? Right? You just base this on the true region. Okay, let's do another one. We'll make it as meticulous as we did this one, okay? So make an x and y axis with those markings. And I will use my ruler to help me make those. And it's assumed that every is a scale of 1 in every direction, okay? This is going to fit. Let's make a 1 point here. And we're going to call this, so that's 0, 1. And then we're going to make another one at 4, 0 here. So 0, 1 and 4, 0 are our 2 points that we're using. And we're going to make a dashed line this time. Did you shade already? You probably did, so I'm just going to keep it at. I wanted to do a reverse, but too late. Okay, so let's do this one maybe a little quicker. In this case, I am going to use the 2 points that I started with anyways. So your rise, right, is just 1. And your run, your run is going there, okay? So in this case, I know that line is dropping, so it's -1 over 4, right? Rise and run. And it's going to be a negative because the line is dropping from left to right. And my y-intercept is going to be 0, 1. So for the second step, all I'm going to do is this. Y, I'm going to leave this blank for now, -1/4 x plus 1. You fill this in by looking at the line, okay? So two things you need to remember. This takes care of the solution region and whether or not the line is dashed or solid. Since it's a dashed line, it's just going to be, let me just go back up. It's going to be one of these here, right? So we know that the true region is below the line. So it's going to have to be a y is less than, and you're done. And I'll just make a note. True is below, and it's dashed. This one will make it, maybe just add that it's solid, right? I added solid up here and dash down here. And that's how you do these types of questions. Okay. All right. So both examples had regular shading involved, but that doesn't really matter. It's try to figure out where is the true region. Okay. All right. What I'm going to ask you to do for the rest of today, maybe I'll just write it down here. Okay. Worksheet number 2. You're going to do the rest of the questions there. So that would be 9 to 13. That'll be right now during class that I'll give you time to do that. Okay, so plus, I do not have a copy of it. Does anybody have like all the worksheets on them right now? Like the package? Anybody have that on them? Would you mind? I know which one I'm talking about, but I want to show everybody at home. So the next one, after you're done that one, I need you to practice a bit more. I'm going to ask you to do, I'm fairly confident that it's in your package. Just have to find it. Right here. There's this one right here that I want you to do after, okay? Inequalities worksheet. If you don't have it, okay, I will make it available via PDF today as well, okay? So if you don't have this one, that's what I'm asking you to do, okay? So you should be able to finish the 9 to 13 today. 13 is a little tricky. Just look at the answer key and it should make sense. I'm just plugging in those points into the inequalities to see whether or not they're part of the solution. If whenever you plug in points and it's true, like at the end, after simplifying it, then it is part of the solution. If you plug in points and the final expression is false, then they're not part of the solution, okay? So go to start with worksheet 2, the one you started yesterday, but now you're doing 9 to 13, and then you do that inequalities worksheet, which I'm also going to post, which has a bunch of graphs, and you're supposed to come up with the inequality on that one. Curious to see how you do that one. But you're only going to do 1 to 6, okay? Over here, make sure you note that because the back is a little crazy still for you. So go to that worksheet and just say 1 to 6 for now, okay?